nuts, bolts, axles, gears, coil springs, washers, etc. These are the basic application where plain carbon steels are used. Now alloy steels, again there are steel in which elements other than carbon are added in a sufficient quantities to impart desired properties such as wear resistance, corrosion resistance and electric or magnetic properties. So as we see earlier, that basic reason behind adding extra element in alloy steel in carbon steel, right, is here shown below, right. Now let us understand alloying elements added are usually nickel for strength and toughness and ductility. Chromium we generally add for hardness and strength and for corrosion resistivity. Tungsten we generally add for hardness. We add generally vanadium for tensile strength. Manganese are added in amount of more than 1.5% to generate high strength property in object. Silicon we add 0.5% for high elastic limit, cobalt for hardness, right, and molybdenum for extra tensile strength. So these are the extra element which we add with the reason why we are adding. Now advantages of alloy steel: high tensile strength, fatigue strength, good wear resistance, high resilience, toughness and good creep resistance. These are the basic reasons and basic advantages of using alloy steel, right. Now there is limitation of using alloy steel. It cannot cast into intricate shape. Again we cannot make complex shapes from alloy steel. Again costlier than cast iron. So alloy steels are costlier than cast iron. Application of alloy steels are high tensile nuts and bolt, turbine blades, gear, coil spring and leaf spring. These are the application of alloy steels. Now let us understand high alloy steel, or we can say stainless steel, right. Earlier we understood plain carbon steel, then we understood alloy steel, and now this is a high alloy steel. In other words, we can say stainless steel. So we now onwards understood three type of steel, that is a plain carbon steel, alloy steel and stainless steel. Now let us understand stainless steel. Iron based alloy containing at least 12% chromium are called stainless steel. So in a stainless steel there should be a chromium minimum 12%, right. As name suggests, this steel should be stainless. It means it should possess high amount of corrosion resistivity. It should resist corrosive environment and can be useful in all kind of corrosive environment, right. So as we know, chromium always increase corrosion resistivity in material, so we have to add chromium more than 12% in particular material. Then that iron based alloy will contain corrosive resistivity and that will become stainless steel. So that is the basic phenomena of stainless steel. Now let us see properties. High corrosion resistance. Heat resisting properties of these steels are improved by adding of nickel and molybdenum, right. This is the basic property of stainless steel. Where we can apply, where we can use stainless steels, we know chemical handling equipment, because almost all the chemicals are very reactive and this can cause corrosion in metals, this can cause corrosion in iron based ferrous metals, right. Now food processing equipment and boiler cell. These are the several applications which I have mentioned here. There are also another applications we can find of stainless steels like medical equipments, right. Now we are switching over to non-ferrous metal. As far as we have discussed ferrous metals and ferrous alloys, now onwards we will discuss non-ferrous metals and non-ferrous alloys. Metal containing elements other than iron as their base constituent are usually referred to as non-ferrous metals. Now dear students, please keep in mind that in non-ferrous metal or non-ferrous alloy there will not be presence of iron, there will not be presence of Fe, right. In some of the cases, in exceptional cases, there may be presence of iron or Fe element, but in a very minor amount, in a minor portion, right. So In a non-ferrous metal and in a non-ferrous alloys, metal like iron and Fe, right, will not be present at all in a major portion, right. So main constituent of non-ferrous metals are always other than iron, right. Now non-ferrous alloys preferred because of following properties. Why we have to use non-ferrous metal and alloys, right? Because corrosion resistance. As we know, ferrous metals and ferrous alloys always have a lesser corrosive resistivity, right, whereas non-ferrous metal and non-ferrous alloys always have a greater corrosion resistance. Second advantage of using non-metal is good electrical and magnetic properties, right. Third is castability, and fourth is softness and facility of cold working. Now non-ferrous materials we can classify it, that is copper alloys. Another two types of copper alloys is brass and bronze that we will understand later on. Then it is a babbitt, second type of non-ferrous materials, and third is aluminum alloys. These are the three main types of non-ferrous materials. First of all, we are going to understand copper alloys, as far as it is very important of our GTU subject, GTU syllabus, right. So copper alloys, copper is one of the most widely used non-ferrous metals in industry. It is soft, malleable and ductile, and is a good conductor of heat and electricity. So we can understand the importance of copper alloys, right. Again, the various alloying elements used in copper are zinc, tin, silicon, lead, manganese, phosphorus and beryllium, right. These are the basic various alloying elements which we generally add in copper alloys. Now copper alloys are basically divided into two groups. This is brass and bronze. If copper is alloyed with zinc, in other words I can say if copper is mixed with zinc, then that particular alloy will be called brass, and if it is alloy with tin, right, then it is called bronze. In other words I can say if copper mixed with tin, then it is called bronze, right. So brass possess zinc and copper, and bronze possess mixture of tin and copper. Now what are the advantages of using copper alloys as brass and bronze? That is high thermal conductivity, high electrical conductivity, good corrosion resistance, excellent bearing properties. These are the advantages of using alloys like brass and bronze. There are disadvantages, which is high cost and low strength. Whenever we are using brass and bronze, we have to face these demerits, and that is low strength and high cost, right. So these are the main two types of copper alloys, is brass and bronze, and we understand advantages and disadvantages. Now type of copper alloys, the first type is brass. It is alloy of copper and zinc. As we know earlier, there are various types of brasses depending upon the proportion of copper and zinc. Zinc percentage varies from 5% to 45%. The ductility of brass increase with the zinc percent, but beyond the 37% there is a fall in ductility. So we can add particular zinc up to the degree of 37%. If we are increasing more than 37%, then there will be fall in ductility. Okay, so this is the basic characteristic of brass. Now we will understand advantages of brass, right. High corrosion resistance, low coefficient of friction, good bearing properties and good machinability. So we can easily do machining operations on brass. It also has corrosion resistance which is very high, also low coefficient of friction, also good bearing properties, right. Now disadvantages of brass is low strength and high cost, right. Brass has comparatively low strength, and we can understand that particular copper alloy has a high cost. Now application of brass is sliding contact bearing wires, tubes and locks. These are the basic applications. Now we will understand bronze, which is the mixture of copper, right. It is alloy of copper and tin. There are various types of bronze depending upon the proportion of copper and tin. also phosphorus bronze. Here also copper is present in 89 to 90%, tin presence in amount of 9 to 10%, phosphorus present in amount of 1.3%, tin bronze in which gunmetal, right, copper present 96%, tin present in amount of 10%, zinc present in amount of 2%. In silicon bronze, copper amount is 96%, silicon amount is 3% and manganese amount is 1%. And then in aluminum bronze, copper present in 86%, aluminum amount is 10% and iron amount is 4%. So these are the different types of bronze. Now we will see the advantages of bronze. Advantage of copper alloy, and particular I can say bronze, is high corrosion resistance. Again, as we see earlier in brass, bronze also possesses the high corrosion resistance. Also, it has a low coefficient of friction, good bearing properties and good machinability. Now there are few disadvantages, or we can say demerits of bronze, that is low strength and high cost. Application of bronze are journal bearing, nuts for power screw, centrifugal pump parts, fitting for high pressure chemical plants, right. These are the basic applications of bronze, where bronze are useful in various manners. Now there is another non-ferrous metal, which is aluminum. This is the white metal produced from alumina. In its pure state it is weak and soft. So we can understand easily that if in a initial form it is weak and soft, then we have to obviously add some extra amount of material or elements. So in order to improve the basic characteristic and or to add properties, we add small amount of copper, manganese, silicon, magnesium and iron. Magnesium make it hard and strong. It is also corrosive resistant, low weight and non-toxic. Now advantages of aluminum. Aluminum is high corrosion resistive, low coefficient of friction, good bearing properties and good machinability. Demerits of using aluminum is low strength and high cost. Application where we can use aluminum is window and door frames, riveting the aircraft parts, automobile floor seats. These are the basic application of aluminum. Now the non-metals. As far as we have seen the metals, then ferrous metals, non-ferrous metals, now we are switching over to non-metals. There are various types of non-metallic materials are also used in engineering practice, right. Due to their low cost, flexibility and resistance to heat and electricity, it is very important to use some non-metals in different applications, right. Now we will see different types of non-metals. Generally, as a students of engineering, we know that what is the basic difference between metals and non-metals, right. Metals have good electrical conductivity, thermal conductivity. If it is collided with each other, it will give clinking sound, right. These are the basic characteristic which metal possess, whereas non-metals don't have this kind of properties. Now we will try to understand non-metals, and first non-metal property is wood. Now wood is a relatively low cost material and a bad conductor of heat and electricity. It has also good elastic and frictional power properties and is widely used in a foundry pattern as water lubricated bearings, right. So wood is a very important non-metallic materials and useful in various application. There is a leather also. This is widely used in engineering for its engineering application, for its flexibility and wear resistance. It is widely used for belt drives, washers and such other applications, right. So dear students, as far as today we have discussed various metallic materials. Types of metallic materials are ferrous and non-ferrous metallic materials, and today we have just discussed only two kind of non-metallic materials, right. So in the next lecture we will try to understand and we will came to know that what are the other different types of non-metallic materials, right. And in the next lecture we will understand abrasive, ceramic, glass, woolen, adhesive materials. These all are the non-metallic materials and very useful in engineering applications, right. Today we have just discussed at initial stage, and that was the different properties of material that we have discussed earlier, right. And then we categorize the material in a metal, non-metal and composite. We already understood the metals in a two form, that is ferrous metal and non-ferrous metal. Then we just see two kind of non-metal, that is wood and leather. Extra non-metallic material we will understand in next lecture, and also composite material, which is a third type, or we can say third category of any material, that we will discuss in next lecture. Dear students, I hope you have understood very well. Thank you students.